type of thing. So got to convert everything into the metric system. So they did that for Chattanooga, for Knoxville, for Memphis, for the second location in Memphis, for Nashville. And what they did in their paper is they explained why they selected these different areas based upon demand of this barbecue sauce in this particular area. And this is their location in Georgia. And then this is the facility details in terms of demand, production, on hand, and maximum storage. And then this was the operating cost, as you see here. They calculated in the insurance, the labor, the electric, water, operating costs per day for each one of the facility operating sites. When they went into the vehicles, in terms of trying to calculate the vehicles, here was their vehicle. They elected to lease the trucks going to Ryder, and they says, okay, this was the monthly rate, this was the cost per mile, this was their driver cost, which was a monthly salary, the gas cost, the gas price, insurance for the drivers, and cost per month, cost per mile, and cost per kilometer. And this was the overview in terms of they only used 2 trucks, and it was constantly going, and that was the delay between the runs. This was a map of their supply chain right here with the different locations. This was the route overview in terms of the route to, as you see, Chattanooga to Knoxville, Memphis 1 and Memphis 2, route to Atlanta, and route to Nashville, all from the factory there. And this was, they went into the air number 1, and there was not enough stock at the distribution center, and so they had to make some kind of changes, so they added more product at the distribution center. And they had to do that by adding vehicles and making the deliveries. And here the truck was overloaded, so they had to reduce, and you see how all these calculations are here. That is what you will be keeping track of as you go through the project and everything. And the third air, shrinking storage space, well, you can see that that's going to happen as you see the trend keep going up over here. And that's what you have to start paying attention to. And that's what you learn here in the course to try to do that. And so they went through some of these different eras, and then as a result they said, okay, this was their group learning experience. The things that they did is, with their paper, they also had a spreadsheet. Here was the location, the address, the type of facility it was, cost per square foot, square meter, rental rate, the size, both in feet and meters, the population rate, the annual demand, annual demand for the cube for the market size, the all together here, and as you can see, the monthly demand. Then they did some of the EOQ calculations, as you see here. These are some of the EOQ facilities that they elected to do for both the reorder costs here, holding cost, monthly demand, and EOQ facility. And as you see, here's the manufacturing. Okay, what happened to labor now? Okay, they also went into labor, and when they went into labor, here was the daily operating expense, and what they did is they went through ONET, and they got some weekly salary amounts at different areas, and they also went through the Bureau of Labor Statistics so as to get your hours per week, the average range, benefits, the weekly payroll, daily labor expense, and the monthly labor cost. And here was the different employees as it related to the different facilities, as you can see here. And then the other thing was let me see, they come up with this is their cost spreadsheet. As you see, their income, expense, monthly profit or loss. SCM Globe will produce this for you. And if you, and Mike will touch upon it a little bit as we go through this, but what you have to do is be able to look at the different data that SCM Globe is going to be producing. And what you do is you examine that data because it's going to give you daily data. What you have in terms of each day, the amount of information in terms of sales and everything. All of this is going to be put in, and as you can see in this spreadsheet here, this is the undergraduate class, and so they did it and they were able to put it and factor it all in. And Mike, you probably talk about this and show them how all of this can basically be put into or loaded, yeah, and taken off and put it into their reports.
Yeah, I will. I'll cover
and
that.
As I said, when you come out and at the end of your simulation, you will have simulation data. So you will have all of this, as you see, by day, by each one of the facilities. And so what you will do is you go, this is all of your on-hand report for 30 days. Here's your demand report for 30 days. Here's your production report for 30 days. Here's your in report per facility for 30 days, etc. Your out report and your cost report. So all of these things will be produced by SCM Globe. It will produce the data per day, but it's up to you to be able, and again, the template is provided for you, but you now have to be able to get this information from this template or from the data downloaded by SCM Globe and be able to fit it here into this spreadsheet. And again, this is what the undergraduate students did last term. So by doing all of that, they were able to come up with this result here. And you saw their report, how they reported all of it. Questions? Anybody?
Not yet.
Anybody in here? Anybody online there? Anybody got any questions? For those of you just coming in, okay, let me try to read that. Okay, no questions. Who was it that had a question there? Let me see if I can.
Okay, put on the chat. Drop it, maybe. Well, drop down here and let's go chat. The next yeah. You might have scrolled back.
Okay.
Scroll up, see if there's a.
Okay, I think everybody is okay with any questions here. Okay, Mike, I guess you can take over here, and I'll turn it over to you there. Can you hear me, Mike?
I had myself on mute. I was rambling on. Okay.
Okay.
I was rambling on and no one could hear me. Well, it was just as well. I just wanted to make sure that everyone can see the chat feature there. That would probably be a good way. Dennis and Steve,
yeah.
If I ramble off or I miss something important, just jump right in. And folks who want to ask questions, I think queue them up in the chat box and we'll be monitoring the chat box. Is that a good?
Okay. Yeah, that's a good idea. And of course, people in here, and feel free to just jump in there in the class here.
So I will go ahead and make myself the presenter again.
Okay.
And we will show my screen. All right. So we want to really focus on the Cincinnati Seasonings one, right, Dennis? That's the one that everyone is, or people will be using that as inspiration for creating their own.
Right. That's, I think, one of the easiest ones here.
Yeah.
Mike, I had a question. One of the students here really wants, she said, well, can I play around with all of the different ones? I said, sure, you can play with any one you want there.
Yes, and we're always interested in getting your feedback on that. So she's obviously figured out, folks, actually, if you want to just follow along on your own laptops as we go here, when you log on to your account, and you're going to see in the upper right, you'll always see the navigation buttons in the upper right corner. If you click on the View Library, you'll view the library, and these are the ones that are presently in the online library. So we're going to just pick up this one, and you know, they get progressively more challenging, but I think that once you work through Sensei seasonings, you're really going to get the hang of it. So we're going to click on the import button. We're going to give it a name that I'll use here. We'll call it Sensei Case Study. And then I'm going to save it. When I save it, I save a copy of it to my account. I can go and I can just go back to my account, and there it is, the Sensei Case Study. And from here out, all I'm ever going to be doing is editing that supply chain model and then simulating it to see how it works. And there's a lot going on, but we are always interested in keeping the software as simple as possible. Intuitively obvious is our slogan, which is hard to do. So if any of you folks out there have ideas, we are always interested in hearing them. Some of the best ideas come from people who just see it because it's so obvious, and we've been working with it for so long that we sometimes miss the forest for the trees. We get so buried in the details. All right, so when you bring up your supply chain in the edit mode, you always know you're in the edit mode because all the route lines will be in solid blue. And then what you're going to see here is the four entities. And what else I'm going to do? I'm going to click on the help button. And this is a good idea for actually everyone. You don't want to get a whole lot of browser tabs open, but we'll kind of flip back and forth between three of them. Here is my edit screen where I'm working. Wherever you are, you can always click on the help button there. It's going to open up the online guide, and in particular, I'm going to click on Getting Started there. And we know from several years experience now and feedback from students and instructors that if you spend 30 to 60 minutes and you go through the Getting Started section, you're going to come up to speed pretty quickly. You won't know everything, but you'll know what you need to get started, and then you can always look up the rest as you need to know. So I'm not going to read through all that. You can do that on your own when we're done here. But there's some video tutorials. Actually, there's 3 of them. They're each about 10 minutes long. And then there are 4 tutorials. And scan through that. Look through the frequently asked questions. There will be 6 questions that guarantee 80% of you will stumble into. And they can cause a certain amount of confusion. Actually, let me touch on those. They can cause a certain amount of confusion. Please read these. And then, of course, if there are technical problems, when you look at your screen, you can also you can submit a help ticket. So right here, I'm going to go back to the Getting Started, and everything revolves around these 4 entities: products, facilities, vehicles, and routes. That's what we use to model a supply chain. It is a collection of these 4 in their endless variations and their endless combinations. So what you start to see is that this is not a simple linear simulation. It's what they call a sandbox. You can do whatever the heck you want. Some things do work better than others. Once you have the model up, any model, you click on the spicy cube here, you can see a little bit about that. Its price, its weight, its shipping volume. If we look at facilities, we see all the facilities.
One of the comments, though, Mike, is that for each one of you who are now building the supply chain, one of the first things you're going to have to do is you have to define what your product is.
Right.
As I just showed you of the undergraduates last term, they decided on barbecue sauce. And so they had to establish a price, a weight, and a volume for their barbecue sauce. You may want to sell tires. You may want to sell widgets, whatever it is that you want to do. Use your imagination. It's up to you, but you have to be able to put those numbers in. And you do that first in terms of all of this. And you have some type of rationale for establishing that.
This Cincinnati Seasonings is loosely autobiographical. I went to University of Cincinnati and their contribution to world cuisine. Here I linked to the Wikipedia article. They had chili, and these chili parlors would be open at 2 o'clock in the morning when you were staggering home and just had to have, some Cincinnati's finest. So the idea here is that what makes that chili so different and so uniquely Cincinnati is the blend of spices that they use, and you can see the structure that this basic supply chain uses, and then, as Dennis is challenging you all to do, apply that basic understanding of a supply chain and the way it operates to create your own. And when you can create your own, you know that you're really starting to actually understand it. So when you load this up, and the first thing you're going to do is you're going to create your product, my product. It's going to be price of X, a weight of Y, and a shipping size of Z. And you can just Google stuff, look them up online, find out what's happening. You can make, a lot of times people will say, well, gee, I really don't know. I don't know what the exact answer is. And the answer is exact. It doesn't matter that much. Make your best guess and move along. Everything is changing all the time. Structure counts more than getting the last 2 decimal or 4 decimal places of accuracy. So once you define your product, then you're going to define your facilities. What we've got here is we have 1 factory, 1 distribution center, and we have initially 3 stores. And we didn't just generally drop that factory somewhere in the, on the city of Cincinnati. And this is what I encourage you all to do, is click over to the satellite view and take a look. If you're looking to locate a factory, look for areas where there's a lot of parking lots and silver roofs. That probably means it's an industrial park, either that or it's a shopping mall. So either way, look, here we go. This is the factory. Now, obviously not a metal bending factory, but this is a factory where they mix spices and make the spicy cube. And then from there, we have created a shuttle bus, a little truck actually, medium-sized truck, that is running back and forth all day long up to the distribution center. And people say, well, gee, I don't know where to put my distribution center. And the answer is, well, what did you just read and what did you just hear in your lectures? And one of the things that you're always going to hear about, where do you want to put a DC, is that you want to put it at a transportation node, places where different modes of transportation come together and cargo could be exchanged. You want it to be easy access to what your main mode of transportation will be, which in this case is trucks. So if I zoom in here, golly, there you are. That looks to me like where I would put a distribution center. And so we dropped it right there. And you can zoom in, you can see the trucks, you can see the 18-wheelers. So this is also something that adds realism. You don't have to just randomly drop these facilities here and there. The more accurately, or the more thought you put into where you're going to position those facilities, it will result in better operating supply chains. So then the next thing is
that becomes extremely important when you're trying to locate your retail facilities there as well, because your retail facilities will go into usually a city, and so now you have to determine, how am I going to transport the material to the retail store? And you say, well, let's just say I have an 18-wheeler. Well, if you have a large truck, perhaps the truck cannot go into the retail center in the city. There's no place to unload, or they can't get in. So these are some of the logistics that you have to look at when you look at the retail center. And you can't say, I'm going to locate the retail center out in the middle of nowhere just so I can transport material there, because you want high traffic area. You want something where people are going to sell it. So that's how you have to be able to have trade-offs and everything. And it's all your decision to be able to use your creativity and to try to come up with this.
And that as you go through this process, you're really going to start to do what you would actually be doing if you were managing a supply chain, if you were related to the people who are opening new facilities, new stores. What you're doing here is going to be directly related to what you would do on the actual job. And while Dennis was talking, what I did was I went into the online, because there is an online introduction to Cincinnati Seasonings, which will get you started, and then of course Dennis is going to guide you where to take it from there. But in the section here, the second challenge, first just do whatever you have to do to get it Chrome for 30 days. And we do say that when you first start working with a simulation, play around with it. And that means don't agonize, don't sweat the small stuff. Try it, see what happens. Throw money at the situation, because you can always come back and fine-tune your decision. You will come back and fine-tune your decision, so you do not need to get it right the first time. Quite the opposite. Just try stuff. Start to get a feel for what happens. So right here, we're saying VP of Sales tells you the address for the new Chicago store is going to be right here, 1840 North Clybourne Ave. And then there's also going to be another store in Columbus, Ohio, but they're not quite sure where that's going to be. And he says, so just drop it somewhere near the I-270 expressway up in the northwest side of the city. So let me show you. When you know where the exact address is, on the edit screen in the upper left is a window, and we're leveraging that capability that you see within Google Maps. We just typed in, I just cut and paste the address there. Google suggests that. Yep, Google, you know it. And so here it is. I'm going to now switch over to the satellite view, and I'm going to turn off that. And I'm going to turn off that as well. And here it is. Here is the actual building where the new Chicago store is going to be. And when you're searching for your own stores, if what your product is going to be, you're going to look for places where it would be good to locate a store to sell that product. You'll be using cityfeet.com, but you'll find that location in Google Maps using SCM Globe. And then to Dennis's point about when you then have to create a vehicle to serve that store, bring it the inventory to meet demand. Well, look at this. As I zoom in right here, that's a big truck pulling out of the loading dock there. And again, we leverage all the capabilities of Google Maps. I'm going to just pull that little street icon guy, and I'm going to drop him down there. And lo and behold, there I am. I'm looking at the loading dock for that building right there. So, and I could, if Dennis says, well, how do you know you can get a big truck up there? Just take a little screenshot. Boom. 'Cause right here, boss. That's the answer. I know I can get a big truck up there because take a look. So a lot of this stuff is, we did not build a lot of arbitrary complex rules. There are some checks. You can't overload trucks or vehicles. We'll check for that. But we didn't otherwise build a lot of arbitrary logic in here, because you can all see, everyone can see what's feasible. If this was a store located downtown in the middle of the loop in Chicago, that might be a different thing. I do not, and again, can you send a great big 18-wheeler downtown? Well, what you would do is you would take a look. Do you see any 18-wheelers on the street here? For a lot of these stores, you're either going to be delivering, at midnight when they might let the larger trucks in, or if it's during the day, you're going to be using smaller delivery trucks to buzz around. And so those are some of the things that you want to think about. It adds realism.
One of the things that with this class is a little bit more unique than some of the other classes is that many of the formulas that you either have learned in some of the other classes, such as your reorder point, your safety stock, your economic ordering quantity, all of these things, and you will learn that in this class here. You will not just be calculating the problems, you will be able to calculate that, and that's going to tell you, based upon the demand, okay, how big your facility is going to be. How big of a stock do you really need? Do you need a 1,000-foot warehouse if you only have 500 foot of stock type of thing? So it's up to you to calculate things like that. The other thing, and that was in one of the first slides that I showed you in one of the projects that the graduate class did, is they did the calculations first, and they come up with a lot of numbers, and they got the right answers, quote unquote, because they figured it all out. And then they went into the simulation, they found out, hey, it didn't work in the simulation. And why? It wasn't because they were wrong, it's because the simulation is just that. It's there to simulate reality. And sometimes trucks break down, sometimes people get sick, sometimes the roads are closed because of a snowstorm or something. So is it made when the formula says it should be made? And so now, in reality, the supply chain manager has to react to that problem. And so what this does is forces you to apply the theory of the different formulas, the academic type stuff, but now apply that into real life situation. You now have to make corrections. And that's why, you know, I have this example in the course here.
And to Dennis's point, at some point, I think first you're going to feel like, you know, you're just getting your head wrapped around how this all works, and then you're going to start looking at the details, and then there's a point where students begin to realize that there are deliveries that don't happen. Hey, I want a truck to show up every day and drop off 30 items, and guess what? It didn't. One day it didn't, and then it caused my supply chain to crash. And that's old software joke. That's not a bug. That's a user-friendly feature. So the idea here is that in the real world you could never, well, you will not be successful if you plan for the supply chain to run perfectly all the time. You always have to have safety stock at your facilities to cover those days when an expected delivery did not show up, as well as you need to have a little extra room in your warehouse facilities to cover those times when some days you get 2 deliveries when you only thought you'd get 1. So you cannot engineer things down to, you know, a 0.057 meter tolerance. Supply chains are messy sometimes. So that's in there, that's in the simulation, and you'll come up against that as you work on it. What we have here, we're looking at this one route that goes from the DC up to the Indianapolis store. I've highlighted the truck that runs it. Whenever I click on any of these trucks, it'll show me the route that it is taking. So I can see truck number 4 is actually a multi-stop. It's going to Indy, up to Fort Wayne, and then back. And if I click, I've got the truck highlighted. Now I'll click on the route, and we'll take a look at that. So we can see that what's going on there, and not that particular delivery route. We've got truck number 4 is a medium-sized truck, and it is going to Indianapolis. It is dropping off 20. See that right there? It's going up to Fort Wayne, dropping off 30. So that really is, we've taken a look at the 4 entities, the way we've defined them and combined them and placed them on the map to create our model of the supply chain. And then the question is, well, gee, I wonder how this works. So when we click on simulation, it will show us how it works. And here's where the point about, we did all the calculations and it should have worked, except it didn't. And that's what the simulation will show you, is that this is a relatively simple supply chain. The ones that you'll encounter out in the world are going to be, I bet, more complex than this, and yet this is plenty complex, you'll find as you get into it. And what you start to see is that you thought you had it all, you think you've thought it through, you know, you draw out your numbers on paper. It looks right. It should work. And it doesn't, because there's more going on. Everything affects everything else. So all we have the computer doing here is doing the math. I'm going to click on this play button. There's a lot of math going on here, a lot of math. And we let the computer do that because I like computers to do the calculations while I do the thinking. Not crazy about computers telling me what to do. All right, so this is just saying on day 2. What I'm going to do, I think, maybe is I'm going to pull out. So, Dennis, how many people here on the call have seen this already? And now, just so I can use the time wisely, do I want to go into some of the basics of how it's using, or do I want to go into more advanced topics?
I think for probably 90% of them, it would be brand new.
Okay, so we will take a little bit more time here. So what we've seen now is this first supply chain model. This is just the first iteration. We have a problem on day 2. And it says right there, we can see it, not enough storage capacity in Fort Wayne. So now what I'm doing is I'm flipping back and forth between the 2 tabs. I've got my edit tab open right here, and I've got my simulation tab, also known as the sim tab, and then I have my help screen over here. So I can, kind of look into more detail as I need it, but not to worry too much about more detail, because everything you need to know is right here. If you went through the getting started, and what we say is throw money at the situation, do whatever you think needs to happen to make this supply chain run for 30 days. So what we're going to do, we know, and we keep the sim tab open so you can see what happened here. All right, not enough storage in Fort Wayne. Okay, this is simple. We're just going to make more storage in Fort Wayne. So I'm going to click on facility. I'm going to click on the Fort Wayne facility. Here it is. I'm going to say, okay, if it only has 850 max storage, well, what happened if we give it like 1,600? Now, my rent cost is going to go up, obviously. I've added a lot more storage space. And this is the equivalent of where in the real world. And also remember to click update. If you don't click update, it won't update. And then we're going to go back over here to our sim tab, and we're going to reload that supply chain because we need to synchronize between the changes we just made on the edit screen with our simulation screen, and then we're going to run it again. And the point I was going to make here about just quickly adding more storage space to the, click on play there, quickly adding more storage space is that it would be as if you called up your local public warehouse, and they would have their vehicle show up at your shop and pick up or deliver whatever they needed, shuttle it back and forth between theirs. So it would literally be as if you had just added a new extension onto your shop, although you will pay for it. So, and we are paid for it up there in Fort Wayne. And as I click through, I can see a little bit about what's happening to my on-hand inventory. Here's Fort Wayne. It continues to go up, which, is a red flag. You don't want inventory, on-hand inventory, to continue to go up. Little hint on that one. It just means you're stocking up too much inventory there. So now our second problem is we have run out of Spicy Cube in the Louisville store. I click on OK. Here is that. And if I go take a look at Louisville, yep, you can see I am not delivering enough material down to that store to keep up with daily demand. So what I'm going to do is and here's a little snapshot of what was happening at that facility at the time when we basically, my quantity on hand went to -20. So I could not meet customer demand. I was 20 short that day. All right. So now what I'm going to do is I'm going to go back to the edit screen, and I am going to go. I know that what I've done, we're using what is called the hub and spoke distribution model, standard practice in the distribution biz, where you will base all of your trucks at a central DC. You get some economies of scale there on being able to assign them multiple routes if you want to, certainly economies on the maintenance and the other related costs of running those trucks. But I could have put trucks out at my stores and had them run in. You can do that. It will work. It will not be as effective, though. What you'll see is standard practice that you see in the reading and you hear about in the lecture will also be your best response to solve these problems here. So this is not just an arbitrary game. I'm going to go to the DC where I know I have all my trucks. I am going to now take a look at the vehicle.
Mike, I think I just lost your sound.
Oh boy, I hope not. All right. Do we have?
I can still hear you.
You can? Okay.
Yes.
Dennis.
Dennis. Everyone else is. I don't see any comments.
Okay, Dennis, because he's got some folks there in the classroom with him.
Oh.
Okay, we hear you now.
Okay, good enough. Good enough.
Okay.
Clear that up. All right. So what I was just saying was that to solve this problem with running out of product down in Louisville, I went to the DC, which is where I have my delivery trucks based. If I click on a truck, I can see where it goes. Truck number 2 is running down to Louisville. Truck number 3 is the one that goes out to Indy. Truck 4 was that multi-stop guy. And then truck number 1 also runs down there. So I go, hey, what's the matter? I got 2 trucks running down there, and yet we're still running out of product. So when I look at this truck, truck number 1, I see it's a small truck. When I look at truck number 2, it also, I see, is a small truck. They could only carry 40, 40 of the cubes. We made those cubes in a cubic meter so we could do the math very quickly. And when I go back to my SIM tab, I can see my demand per day in Louisville is 100. So even if I maxed out both trucks and ran them down there once a day, I wouldn't keep up with demand. So I might decide, let's swap out that little truck and swap in a big truck. So I'm going to pick that one. And it comes with a bunch of default values. All the facilities and all of the vehicles come with default values, but some of you, as Dennis has pointed out, are going to do your own research. Go online like this. You could either accept the default values for the trucks, operating expenses, etc., but we realize these numbers change practically by the week, depending on fuel costs, labor costs, number of hours of operation, you name it. So, you could find out if you went to a truck rental like Ryder or any of those truck rental websites, you can find out a lot about the data that you'd need here. We'll just accept the defaults for now, and I am going to update that. So now, all of a sudden, my vehicle 2 is not a small truck, it's a large truck. And if I take a look at the route now that vehicle is running, I can see here it is. It's a big truck. I need 100 a day. When we looked at that, I needed 100 a day in Louisville. So I'm going to say, what the heck? Let's have that truck run 100 of those down there every day. I'm going to update that. And then what I'm going to do is I'm going to say, why do I even need that second little truck running down there? So maybe I could just delete it. So here it is. It's truck number 1. It's just that small truck. I don't need it there. I can handle it all with the big truck. I'm going to click on remove, and I'm going to remove that truck as well as it will also remove its route. Close that out. And so now if we take a look at what's going on at the DC, we can see we only have these 3 trucks now. What I'm going to do now is I'm going to go back to the SIM screen, reload that. So I hope you start to see that what we're doing is we're interacting with that model. We're seeing how well it works. When it finds a problem, it points it out to us, and then we take corrective action. We can take any number of things. I just made one big truck there. I could have said, for instance, well, let's have the 2 small trucks run more frequently. Why not? That would get more product down there. It might actually meet demand. We're going to go on the assumption that 2 little trucks running more frequently would wind up costing a little bit more than 1 big truck running just once a day, which I think is probably a pretty good assumption. But you could try it out and see. That's the whole idea here with these simulations, is plug in the numbers, do a little research. What is it costing you to run those little trucks versus the big trucks? See what happens. And now as we're going through here, I can see where my on hand, I can see that that's all flattened out, because that's good. I'm down there in Louisville. I'm meeting demand, so we have a flat line. Good. Not enough storage capacity in the seasonings factory. So in all of these case studies, there are a few, 2 or 3 pitfalls we deliberately put in there. In Cincinnati Seasonings, you're seeing the first 3 that we put in there deliberately, but after that, your simulation will take its own trajectory based on the solutions that you turn to when you had these problems. And I will say that the solution that we're showing you here is a good, competent solution. It won't get you fired if you actually did this, if you actually did work at Cincinnati Seasonings. But we had a student at a school up in Wisconsin in the winter last year. He was in the business, so he would look at this with that fresh eye. He came up with some solutions, which I won't tell you because that's for you to discover. But he came up with some ways to make a major reduction in operating expenses, rent expenses, etc. Just really, I'm always amazed. I think I'm so smart, and I missed something that was a brilliant, simple, obvious solution. Maybe some of you will come up with that as well. So now what I'm going to do to just get more space there at the factory, first I'm going to take a look here on hand. A good indicator of a lot of things. On-hand inventory, I see it's going up at the factory. At the distribution center, I see it's going down. We'll look out at the stores like Louisville. See, we matched supply and demand, so we're good. That's what you want your on-hand lines to flatten out as much as you can, and then make them flatten out at a lower level. You'll always have some because that's your safety stock to cover for missed delivery days. And again, there's much more of this online. If you look through some of the getting started, we have links to other stuff. So those patterns all mean something. But generally, we're still going up at most of the stores. Or on-hand is going up. Hint, on-hand should not be going up at the stores. You can reduce a lot of expenses and a lot of on-hand inventory by leveling out those on-hand lines. So what we're going to do here is we observe that if I'm going up at the factory, I could just add more storage, just like I did at the Fort Wayne store. Or I could say, hey, it's going down at the DC, and I really do want to be shipping product out of the DC. Maybe instead of adding more storage at the factory, why don't I just move more product more quickly to the DC, and then I would be good. I wouldn't have this problem. So if I zoom in here, and what I'm going to do is I'm going to go back to my edit screen. I'm going to select the factory where we did actually station one vehicle at the factory, and here it is, the factory truck. And that truck, if I take a look at its route, what I'm going to see is it just pretty much, and I'm going to close out some of these boxes here. So it's pretty much just buzzing back and forth. I can see that route is about 30 minutes. Actually, it takes 30 minutes to run up there and back. Distance 27.43 kilometers. And every time it runs up there, it is dropping off 30 of them. Delay between departure of 8 hours. So it runs its route, it comes back to the factory, waits 8 hours, and runs again. So that means it's going to run about 3 times. Since 8 goes into 24, 3 times. It's going to run about 3 times a day. That means it's going to drop off total in a 24-hour period, about 90. But when I look at the factory, what the production is, if I go back to my sim screen, I look at the factory, we're producing 350 every day. So obviously we're building up because we're only moving 90 right now. So maybe I'll just move more. Again, I could do something like I could make this truck run every 2 hours instead of every 8 hours. Or I could make it a large truck, you know. I could make it a helicopter if I want and have it go even faster. You can do anything you want. You can do anything that is not expressly forbidden. All answers, as long as you can back them up, explain your reasoning. All answers are valid. Some answers will be better than other answers. And better is always, it runs for 30 days at the lowest operating cost, lowest transport cost, and the lowest amount of on-hand inventory. That is the objective measure of better. And you'll all find different ways to get closer and closer to that. So what I'm going to do is, what the heck, I'm just going to make it a large truck. I'm going to update that. I'm going to, when instead of dropping off 30, I know I can get a whole bunch. I know that my large truck, actually, the carry volume is 110. So what if I just load up that truck? We'll drop off 110 every single time. We'll update that. We're going to go back to the sim screen, and we're going to click on that reload supply chain, and then we're going to run it again. And another thing is, as you start to get the hang of how this is all working, I think at first it's a good idea to don't run your simulation so fast that you don't really see what's going on. But after you start to get the hang of it, you're iterating through. You can run these at faster and faster speeds. So I could say let's run that run at the fastest. Click play there. It's going to buzz away. And again, as I flip through and look at my on hand, there's a lot of upward pointing lines.
Mike, did we lose your voice again?
Did we? I hope not. Can anyone else hear me? Oh boy, what is going on with this?
I can hear you, Mike.
Yeah. Dennis, Dennis, I think it's on your end.
Yeah, the other people can hear you. It might be that the microphone is on there.
Right.
And it starts picking up sounds.
Right.
Shuts you off.
Right. Can you hear us,
Yeah, I hear
Dennis?
you. Yeah, I hear you now, yeah.
Okay, good. So anyway, we just ran. Now, when we did this, of course we ran into a problem here, but we are past the 30-day mark. We're up here at day 35. So although this may not be the most elegant solution, it is a solution to get your supply chain to run for 30 days. And the reason for 30 days is that is the standard planning cycle. Most of the supply chain professional societies, certainly a lot of the textbooks now, are very much in favor of a technique known as S&OP, Sales and Operations Planning. The idea is that we steer our companies through an uncertain world in 30-day increments. So we work our way through the world in 30 days at a time. We do not try to, it's fine in an abstract sense to forecast what your supply chain might do over the course of a year, and you could do that here, but it doesn't really mean anything, actually, because who can tell what will happen? The notion is in 30 days you can get a general idea of what's going to happen, so planning for 30-day horizons makes sense. That's what the S&OP cycle is about. That's why these simulations, we really focus on that 30-day number. We've gotten this to run for 30 days. Now our challenge will be to circle back and start making it run for 30 days at lower transportation costs, lower inventory on hand across your supply chain. Wherever you flip through here and you see the online numbers are going up, right here, this is a case where you suddenly actually got 2 deliveries in a day when you're only expecting 1.
So, Mike, I think it's a good time to show them how to export to Excel so they can analyze that and create a plan.
Right here, do you want to talk it through, Steve? I mean, right here.
Ahead.
So where it says, when you have
from anybody online there, because I know you have, there's a lot of people in Miami area, and I know in the online course there will be several folks or a few folks from South America calling in. And again, Mike, why don't you talk one bit about how they would do this, again, remotely, virtually, how they would get together in groups?
Yeah.
Okay, show a spreadsheet and then show a share.
Here's the spreadsheet. Now we just whenever you stop your simulation by clicking on the stop button, like if it runs past 30 days, you can just click on the stop button. You're there. Or when it finds an error, it will stop itself. And then this button will appear, Export Results to Excel, which when you click on it, it will do that. Of course, it can be any spreadsheet, Apple numbers, Google Sheets, anything, doesn't have to be Excel. And then when you click on the downloaded spreadsheet, here it is. What it's showing you is we've divided the simulation data into segments. This first segment is called your on-hand report, and it's by day that the simulation ran, so it ran for 35 days, and by, I'll open this up, by facility. So by day, by facility, it's showing me on-hand numbers. Here they are. Then it's showing my demand numbers at the stores. At some future date, we'll make that demand somewhat variable, but for now, this is your 30-day average. It's your planning horizon when you do these plans. So then when you talk about production, we only have one place doing production. There that is. Then we've got what is coming in. This is cumulative, but you can see the products coming into a facility. You can see the products going out of facilities. Again, they're cumulative, so if you want your daily numbers, just do the subtraction. And then your facility costs, which are also cumulative. I'm going to minimize that. You also have a lot of that data right here online on screen. So if I click on the Vehicles tab, here are my cumulative running costs for all my vehicles. My products, I can see where they are in the supply chain, both in unit numbers and in dollar numbers. And the console was everything, which was what we just exported there and took a look at. So the other thing...
Mike, you know how to put this into that overall cost spreadsheet, into that template?
Sure, yeah. Let's see what we can do here. When we take a look at that getting started, this is why it's so really important to read through the getting started. Just kind of scan through it at high speed so you'll know where to go and find stuff. On this, how to work with case studies, it's a good little overview, kind of orients you to what's going on. In this right here where it says analyzing simulation data, simulations give you a lot of data, and they do. And we don't want you to get buried in data. So we've kind of highlighted some of the things you want to look at in the analyzing simulation. We give you a little talk about what you can see online, what you can.
And a lot of those different graphs, I would encourage you to put them into your written report and explain them, because that becomes very important. That means that you understand what the graphs are telling you and how to really understand, how supply chain is working.
And then here is a pretty cool thing that some of Dennis's students did, 4 years ago. And it's a little worksheet to help you synchronize, because you're going to learn you need to synchronize production with demand at the stores if you really want to start to get a handle on operating cost and inventory. So this is a useful sheet. You can always click on, print out a larger sheet like that. So the other thing that I wanted to show you, which is this downloading, if we go down here, it's in the part here that's called Analyzing Simulation Data. You can find every screen, in multiple ways. We've linked the cross-reference the heck out of everything, so there's many ways to find it. There's a section here called Download Simulation Data to a Spreadsheet Reporting Template, and we walk you through what's going on, and I won't read it all because you can read it. We do, for instance, you only want 30 days, so we ran 35 days. Just trim off the extra data. Just trim it off. Not a problem. Someone wanted us to write a program to do that, and we thought, gee, I don't know. Maybe you could just trim it off. It'd probably be easier that way. Cost us an arm and a leg to write that program. So what we did here was we on Google Sheets, and if I'll just click this link. So here it is on Google, and you can download it. Click on File, and then just say I want to download it as, and you can download it as Microsoft Excel or Open Document format. One of those two would be the one you want. So if you just say, yeah, give it to me as a Microsoft Excel spreadsheet, it will download it. There it is right there. Oh no, that was my simulation data. Whoops, the converter failed to open the file. Yikes. So we're going to get rid of this. Don't save anything. Don't save anything. We're going to download that again. Download it as I don't know. People should try that. Actually, try it now. Do what I just did. I don't know why it's not converting it. See if that's something that's going on my computer. Maybe because I'm running this. If other people could try it and just see, click on File and then go Download As. For some reason, I think it's something on my computer that's causing this problem, because worked just fine this morning. But put something in the chat box. If other people are finding there's a problem, then there's a problem. We'll fix it. But anyway, there it is. It's on Google. You can download it.
I think that the class last term had a little bit of problem with that too, but
Really?
once or twice, and then it worked.
Oh.
We tried it again, and it worked.
Okay. Yeah. Web-based stuff, sometimes you have to kind of, but unless someone speaks up here on the chat, I'm gonna assume this was just a problem happening on my computer, and if you do speak up, then we're going to dig into that a little bit further. But otherwise, then once you've downloaded it, we give you instructions.
Anybody got any questions of anyone who's left there? And
all right. Last thing maybe we'll talk about is how to share.
I can't hear you again.
It must be on your side, Dennis. I assume everyone else is hearing me. Is that true? Steve, are you hearing me?
Yes, I just put up on the chat box what's going on.
Yeah, okay. Okay. So the other thing, the last thing we'll talk about is how to...
Hey, Mike?
Yes. Yeah, Dennis? I think it's on your end, Dennis. Can you hear us now, Dennis? Can you hear us now?
Steve, Mike,
yeah.
Anybody? Can you hear us?
We hear you. I guess you're not hearing us.
Yes, we hear you. We do hear you, Dennis.
Sounds like other people on the call can hear. So there's something the matter with your speaker there. It's cutting in and out. And I don't want to waste people.
Mike?
No, we can hear you, Dennis. You just can't hear us. So for everybody that and we're recording all of this, and so you can listen to it again. There is a way to download and share your supply chain models. It's if you just go to the user guide, and it's also linked in through the Getting Started section. But user guide, you can always, if you just click on the user guide, you'll see a full table of contents of everything you ever want to know. So it's there. Everything can be found at least 7 different ways. And when you go to this download and share, it will walk you through with some screenshots about what to do. I'm going to switch over to the edit model. The edit screen, if I click on options, I can click on save. And what it'll do is it'll create a save state. And then you download that save state, which is, it's a data file with all the information that is used to create this model. You can attach it to an email and send it to Dennis or to your teammates. They can then download that file from the email you sent them and upload it log on to SCM Globe and then upload it. You cannot open the file unless you're in SCM Globe. But once you do upload it, then you can begin editing it, running the simulation, make changes to it as you wish, send it back to whoever sent it, etc. So that's how geographically dispersed teams will coordinate with each other. As someone comes up with a good idea, you can circulate your model, to everybody else. Questions?
You got a question?
Yeah, I mean, just say the options is run with trucks, right? But perhaps just run the supply, the train, right? So we have also the location next to the train that's unload. They probably needed maybe a small truck.
Yes, it's a very good point, because in my course in the spring term, there were some groups that imported different material from China, from India, etc., that come into the port in New York. Okay, well, you just don't take the product off of the ship and put it onto a truck. It doesn't do that. It's stored someplace there, and sometimes for weeks it's stored right there. Or if you take it to be shipped, it's stored there. You know, just because you're bringing something, the ship isn't going to wait for you and take off. You have to wait for the ship to leave. So what you have to figure is what kind of facility are you going to rent there at the port to be able to store it until it leaves. So you have to go through that flow chart more or less and figure all those things out in terms of costing. And you can use it on ships, you can use it on planes, you can use it on trains, any kind of vehicle you want.
And when to Dennis's point, when you're bringing stuff in, you can quickly find out where the ports are. You can just Google them online. But Bayonne, New Jersey, port of call, Bayonne, New Jersey, exotic Bayonne, New Jersey. But look at the size of that storage yard and all those little multicolored storage containers. Look at that. That's where your product will be, and it will sit there for some number of days or weeks. It's got to clear customs, etc. So, create a facility that will be this harbor here, and then from there you're going to load it onto trains or trucks, and you're going to take it to wherever your factory is. So this is, is as realistic as you want to make it.
So there's a lot of things that you can think about going through that. You got another question?
Yeah, when they say the real simulation, like when you say that another group, they threw some values on numbers, and when they went through the SCM software, and then they run.
Right, it didn't run. And because what happens is you will come up with say a safety stock of say 100. And if you keep that safety stock as 100, you'll find out that sometimes you'll run out. Well, wait, according to the formula, I was supposed to have the safety stock. So what you would do is you would say, okay, and remember how Mike was saying, try it, practice with it?
Yeah.
100 won't work. So for it to work, you have to have 150. Even though the formulas say that you have 100, the key part is when you figure out formulas, everything is exact and everything is ideal. However, whenever in real life things happen, deliveries aren't made because of stuff happening. Yeah. And for example, in yesterday's paper, there was a big article about how everybody in Europe and in China are really complaining because of all the customs, because of the Zika virus. They now have to, they're talking about fumigating all of the different containers before they are shipped.
Right.
And so if that happens, there's a big concern about all that because of the time it's going to take to go and fumigate that because of the Zika virus. Now,
shipping costs?
well, yeah, that becomes part of their shipping costs.
Yeah.
Now, it's interesting because who and how can you ever forecast something like this? No formulas are going to tell you this. Something that happened, so now you have to deal with it. And so that's just added on. You can't plan for things like that. So that's the realism part.
They're very concerned with any kind of disease.
Right, exactly. Yeah. I'm sorry, Mike, go ahead.
No, that's exactly it. The formulas, Dennis, how did you put it? You had a great way of putting it. The formulas will point you in the right direction, but it takes trial and error, experimentation to come up with the.
The way I tell my class is that when you have the formula, and if you had any kind of Six Sigma training or anything like this, what the formulas tend to do is it creates a upper and lower control limit. And that's where you want to lower everything down. In a little bit in this class, you'll learn about the bullet effect. And other classes, you probably know what the bullet effect really is. But the bullet effect will be very, very high ups and then high downs. And you will find that in here as you start dealing with the program. When you start fixing a problem in one facility, that will work, but if you don't look at the big picture, you fix it in one facility and you'll break it in another facility. and things like that will happen. That's the bullwhip effect. But the formulas will help you to reduce that bullwhip effect by taking the upper control limit, bringing it down, and bringing the lower control limit up, so that it narrows the ups and downs that you have. So you will see those trends. You will have deliveries, and then you will have demand, delivery, demand, and so you'll have a sawtooth edge like that. Okay, any other questions here or comments from anybody online? I guess that's about it. Mike, if you just want to take 5 minutes or so to explain some of the other cases that are in there, it's just explain, give an overview of what they are about.
Sure.
I think you may want to experiment with them.
If you go to the case studies and just click on that, in approximate order of increasing challenge, we list the other case studies that are available in the online library, and you can click on them. For instance, like this Alexander the Great here actually is kind of cool, and it's based on some work done by a historian and logistician who teaches out at UC Berkeley. And going through his book, he basically figured out what were the routes that Alexander had to have taken as he wended his way after his campaign that launched him into Afghanistan and India. And so we took information there, we modeled it, you can read this, and basically you're challenged to figure out how you're going to get, in this case we just made it, Alexander's army was actually about 80,000 all told, but he would often have a group of about 10,000 leading the way because he didn't want to risk his entire army. If you march your entire powerful army with all their shining armor and they go out to some place and run out of water and run out of food, in about a week you're going to go from a proud and powerful army to a bunch of starving or dead soldiers just that quickly without even having gotten into battle. So there's an interesting perspective that you start to develop by looking at this, and a lot of those issues are, of course, every bit as true today as they were 2,000 years ago. There is another, for folks who are into history and military, there's this campaign. We basically did the same thing, did a lot of reading. We modeled this from the perspective of the Japanese officer in charge of the supply chain that actually in 1944 supported the Japanese invasion of India. They had a real problem supporting the 4 divisions of Japanese that invaded. Turned out to be a campaign that pretty much hinged on the ability of the Allies and the Japanese, their respective supply chains. We model the Allied supply chain, which you can see there in these straight lines, was airdrops because we had enormous airlift capacity. The Japanese did not have enormous airlift capacity, and it was later in the war and they had been worn down, and they were relying on barges, railroads, and mules to get their products through impossible jungle terrain. They fought hard and bravely, but it did not make up for the fact that they ran out of food and starved. And so this is an interesting look at this. Again, a lot of these issues are issues that we all face today. If you take a look at some of the other case studies, like for instance, this disaster response supply chain, Dennis and I did some research and we presented a paper in 2015 at the ITEC conference in Prague. And we have some screenshots from the model. The model is there in the library. You can run it. And then at the very bottom of the write-up, there is a link to the paper that you can download a link of that paper that we presented. So you can see a lot about that. Actually, there's increasing interest in disaster response and humanitarian supply chains, considerable increasing of interest, I think, because we all realize that there are going to be disasters that we all want to respond to in a good way. And then, for instance, this S&J Trading Company is set in the country of Angola in Western Africa, and it is actually loosely based on a real company. A person contacted me about 6 years ago now, and he had read my supply chain book, and we had some conversations. He described his situation. It's loosely reflected here in this case study. Anyway, he's importing products from Europe and America and selling them in a network of stores throughout Angola. It's a good illustration of what happens when you can start using rail instead of truck, especially when the road infrastructure is kind of beat up. And in many of the countries of Southern Africa, Central Africa, the Chinese have spent billions of dollars loaning that money to those countries to rebuild their infrastructure. It's not necessarily because the Chinese are just the best folks in the world, but and they are looking for ways to extract the minerals that are there in Central and Southern Africa. And so why wouldn't they? It behooves them to help the countries that will be their suppliers of raw material to improve their transportation infrastructure, and rail is hands down the most efficient way to move product ever invented yet. The only thing that will be more efficient is when we figure out how to have the beam me up, Scotty mode of transportation. But until then, rail is it, even more efficient than shipping. This one right here is the Java Furniture Company. It is a real company we did some work with. It's a pretty heavy-duty case study, but I would love to get any feedback if people want to do this. We have some people at the graduate level who are using this. So there's, it's all here. We laid it out in probably more detail than you really want to know, but the Zara Clothing Company, I'll leave it at this one. This one is maybe the most complex, and I think certainly the women in the audience know who Zara Clothing Company is, and they're made possible because of the capabilities of their supply chain. They have hands down in the retail fashion business, they have the supply chain that everyone else is trying to match somehow, but they have invested a lot of money. It's a major barrier to entry. You can't just be like Zara without recreating a supply chain with Zara's capabilities, and that will be expensive. So we've modeled it. We've made some assumptions, which we list out here. Zara is a private company. They're not really open with a lot of their data. They don't really want you to know how they do it. But we can make some educated guesses. We did that here. So you could load that supply chain and run it and see what happens. Okay, I think that's a pretty good overview. Yes, Dennis?
Yes, thank you. Any questions before we conclude this? No. Thank you, Mike. Steve, thank you. And for those of you online, any questions? Anybody?